Now, before we go into the solution, let us quickly try to understand. Okay, or maybe let's put a question here for you guys. How is a unit vector applied in a practical scenario? Right? So yes, we've been dealing a lot of questions with respect to unit vectors. How is it practically, or how is it useful in a practical sense? Okay, so think of it. Get back to me. Now, given vector P is equal to 3i plus root 3j plus 2k, Q is equal to 4i plus root 3j plus 2.5k, let vector C is equal to vector P cross vector Q. Now, this is not given in the question, vector C. I've just made it for ease of calculation or ease of explanation. So unit vector along vector P cross vector Q can be replaced by unit vector along C. Now, what is unit vector along C? Unit vector along C is vectors C cap, which is vector C by magnitude of vector C. What is vector C? Vector P cross vector Q. Therefore, magnitude of vector C is vector P cross magnitude of vector P cross vector Q. Now, if this is P and Q, what is vector C? The cross product. I, J, K, magnitude of P, I component 3, J component root 3, K component 2, Q 4, and how do you open this determinant? I times removing these two, multiplying them like this, right? Root 3 times 2.5 minus 2 times root 3 minus we will have removing the column containing J and the row containing J. What we'll have is, maybe I can just erase it for you so that things become really more clear to understand, right? And then we multiply this. What is that? 3 times 2.5 minus 2 times 4, right? And similarly, we have for K, which is 3 times root 3 minus 4 times root 3. Now, when we expand this, 2.5 root 3 minus 2 root 3. 2.5 into 3 is 7.5. 2 into 4 is 8. Oh, this could be a possible, this could possibly lead to an error. 2 into 4, 8. 3 root 3 minus 4 root 3. Okay. Now, evaluating this, 2.5 root 3 minus 2 root 3 is 2.5 minus 2, which is 0.5 root 3. 7.5 minus 8 is minus 0.5, minus 0.5, and 3 minus 4 is minus 1, root 3 minus root 3, right? And after this, vector C is equal to 0.5 root 3 times 0.5i minus times minus is plus minus root 3. Okay, so what is magnitude of C? Will be root of the square plus root of the square plus root of the square plus and plus. Oh, sorry, right? So root 3 square is 3. 0.5 square is 0.25. So 0.25 times 3 is 0.75. So 0.75. 0.5 square is 0.25. So this is 0.25. Root 3 square is 3. 0.75 plus 0.25 is 1. 1 plus 3 is 4. Root of 4 is equal to 2. So magnitude of vector C is equal to 2. Yes, exactly. This is where root 3 and 3 and these complex values make sense, because the magnitude of C is a direct number. You know, it's an integer, 2. Okay. Yes. The beauty of the question, or the numerical part of the question. Okay. Now we have vector C is this, and magnitude of vector C is 2. In which case, what is C cap or what is the unit vector C cap? The unit vector C cap will be the vector itself divided by its magnitude. What is the vector? The vector is zero 0.5 root 3i minus j minus 0.5 plus k minus root 3. Now, why have I not written it the other way around? I'll just take you through that. I mean, why am I still using these two colors to differentiate this? I'll take you through that in a minute. Okay. So let us first divide it. So when we divide this can be written as 1 by 2 times 0.5 into root 3i minus j into minus 0.5 plus k into minus root 3. This further can be written as 0.5 can be written as 1 by 2. Minus into minus is plus. 0.5 can be written as 1 by 2. K into minus root 3 as minus k root 3. Okay. After this, C cap is equal to half into. Can I make this denominator as 2? Right? So now the complete denominator becomes 2 here. So 2 divided by 1 is 2. 2 times k root 3 is 2k root 3. Okay. Now, after this, 1 by 2. 2 times 2 is 4. So 1 by 4 times root 3i plus j minus 2 by 2 root 3k. And when we compare this to the given question, P cross Q is 1 by x times root 3i plus j minus 2 root 3k. These two components remains the same. Therefore, 1 by 4 is equated to 1 by x. And therefore, 1 by 4 is equal to 1 by x. And x is equal to 4. Okay. Therefore, the value of x is equal to 4.